Question 13 is a mixture of non-right angle triangle. We've been given this angle and this side, so happily we've got a side angle pair, so we can use the sine rule to find the length of YZ. But mixed up in this are bounds. We'll come to that later. Let's just sort out an equation for x. So I can say that x divided by sine 130, that's that pair, must be equal to the equivalent on the other pair. So this is 16 divided by sine 25. Okay, making x the subject, I get x is equal to 16 sine 130 divided by sine 25. So let's first of all have a look at the dimension 16 centimeters here. We're told everything is correct to two significant figures. So if I plonk 16 there, what's going to be the next one up? Well, the next one up is going to be 17. And the next one down is going to be 15. And the barrier that defines whether the number you measure goes down to 15 or up to 16 is plonked right in the middle. And this will be a value of 15.5, and the barrier here, 16.5. So this would be the upper bound, and this will be the lower bound of the side xz. Now, you've got to watch out with sine values, because the value of sine 130 doesn't necessarily go up when the angle goes up. So let's put sine 130 in here as our central value. So considering just the number 130, we're only quoting that angle to two significant figures. So the next one up, and I use that word advisedly, is sine 140, and the next one down is sine 120. And in the same way, these border crossings will be at sine 125 and sine 135. There's a real danger to say that sine 125 is the lower bound and sine 135 is the upper bound of the number. I've brought on a sine wave and the blue line representing 130 degrees. So if you now imagine the second blue line I've put there at the 135 degree mark, the sine of 135 has actually gone down. And similarly, this other blue line I've just popped on at 125 degrees, I know the scale's not quite right, but the value of sine 125 compared with sine 130 has actually gone up. So our upper and lower bounds have actually swapped. This is the lower bound, and this is the upper bound. Let's look at our last option, which is sine 25 degrees. Our next one up would be sine 26. And I'm only referring at the moment to the number 25 going up to 26. The next one down is sine 24. And the border crossings would be, as I've indicated, 24.5 and 25.5. Now, do these represent upper or lower bounds? Well, let's just check. Let's say that's 25. If I go up in degrees, so that this is 25.5 degrees, the sine of that angle has gone up as well. And similarly, the lower line, which is representing 24.5, the sine of 24.5 compared with the sine of 25 has gone down. So we're sort of back normal again, that this would be the lower bound and this would be the upper bound of sine 25. So if we want to find the upper bound of x, we want the upper bound of 16 and also the upper bound of sine 130. But the sine 25, we need to have it at its lowest value, such that then the sum will become greater. So this one needs the lower bound. So it's now just a matter of choosing from our table which one of these values we want. So instead of 16, we can write the upper bound of 16, which is 16.5. Sine 130, we want the upper bound, and that will be sine 125. And that's divided by the lower bound of sine 25, which is sine 24.5. Right, calculator time. And we get 32.5927. They're wanting this to one decimal place, so the cutoff will be here. We've got a 927 on the other side of things, so this will round up to 32.6 centimetres. And that's your answer.